Hello and welcome to Section 5.3 of College Algebra. Actually, this video will cover all of 5.3 and just a little bit of Section 5.4. Section 5.3 is the last section that is on homework and quiz number 11, which is due Tuesday, April 14th at 11:59 p.m. Section 5.4 is the beginning of homework and quiz number 12. Which is due Friday, April the 17th at 11:59 p.m. Reminder that Mastery Quiz for Test 4 opens April the 13th and is due Sunday, April the 19th at 11:59 p.m. Remember, all of these times are Central Time. So let's get started with Section 5.3. Section 5.3 has to do with properties of those logarithmic functions that we talked about in Section 5.2. So there are several properties here, and just reminding you that our base of b must be greater than 0, cannot be equal to 0. Also, in keeping with the domain of our logarithmic functions, whatever we're finding the logarithm of, in this case our u and v, must represent positive numbers. And when we talk about r as an exponent, this can be any real number. So there are 3 rules for logarithms. Whether you remember the names for them or not, you need to be able to work with them. So the left-hand side is what we call the condensed side, and the right-hand side of these expressions is what we call the expanded version. And we will be going from expanded to condensed and condensed to expanded in the following problems. What I need you to know is that if we have the logarithm, does not matter what the base is, of the product of 2 or more functions or expressions, we can split those into the sum of logarithms. If we have the logarithm of a quotient, we can split that into the difference of logarithms. And if we have a power on whatever we're taking the log of, then that power can come down in front and become a product. So we'll walk through several problems using these condensed and expanded sides of these expressions. Let's begin with expanding these. It says use the properties of logarithms to expand the logarithmic expressions as much as possible. And if possible, evaluate without using a calculator. Now, if you refer back to the previous page, these problems we're going to be going from the left side to the right side. So we'll take products to sums, quotients to differences, and powers to products. So let's begin with number 1, log base 4 of the product of x times y. We can expand this into 2 logarithms, log base 4 of x plus log base 4 of y. You can put x and y in parentheses individually if you want to, but it is not required. Number 2, we have the natural logarithm of a quotient. So we have, this is going to become the natural log of the top part of our expression, or the numerator, minus the natural log of r, the bottom part of our expression. Now, we can evaluate the natural log of e to the 5th power by remembering the properties of logarithms from the previous lesson. The natural log of e to a power just becomes that power, and so I have 5 minus the natural log of r. That would be the answer for problem number 2. Number 3, again, we have the natural logarithm. This time we have the natural logarithm of a product, so we're going to separate that into 2 natural logarithms, the natural log of 5 plus the natural log of e to the 2nd power. Now the natural log of 5 we cannot do anything with without a calculator, and it said only evaluate without a calculator, so we leave this as the natural log of 5. My T has a tail, sorry about that. Plus, again, we're using the properties of our natural logarithms, and the natural log of e to the second power simplifies to just 2. Number 4, we're again using logarithm of a quotient. This is the log base 2. So we will be splitting this into log base 2 of m, which is the numerator, minus log base 2 of 32, which is the denominator. There is nothing I can do to simplify log base 2 of m. However, I can simplify log base 2 of 32 without a calculator because this is asking the question 2 to what power is 32, and that answer is 5, and that's my final answer. Now number 5 down here involves a couple of different properties. We're putting some things together. So we'll start off by looking at the quotient. So we have the log. This is a base 10. Remember, we don't see it there. That's why it's understood to be 10. So we have the log of the square root of x minus, because we have a quotient, the log of, and I'm going to put this in parentheses, 100 y to the third power. Now we're going to rewrite this square root as x to the 1/2 power. So we have log x to the 1/2 power minus, and we're going to split this into 2 pieces. Because this is a minus, I am going to put this in a parentheses, and we will distribute that minus sign in a minute. So I have the log of 100, because I have the product of 2 functions, I can make this a plus, the log of y to the third power. Now we're going to do a couple of things here. The log of x to the 1/2. Now we're going to use that power rule and make this a product. So I have 1/2 the log of x minus the log of 100, which we will simplify, minus, I have a power here, so this is going to be 3 times the log of y. Again, reminding you that this is the log base 10. There's nothing I can do to this first part. This becomes 1/2 the log of x minus the log base 10 of 100. We ask the question, 10 to what power gives me 100? And that answer is 2. And then we have minus 3 times the log of y. And that is going to be my final answer. Now in these next problems, we're going to be using those properties to condense our expressions. Condensing means we're going to go from the right-hand side of that first page to the left-hand side. So we're going to be putting these expressions back together. You do have to have the same base on your logarithms, and all of these will have the same base. So if I have the logarithm of a sum, or 2 logarithms that are added, this becomes the logarithm of the product. So log base b of a plus log base b of c is going to condense into log base b of the product a times c. Number 7, we have log base 4 of m minus log base 4 of n. So this is going to become log base 4 of the quotient. M was the first expression, divided by n, our second expression. Does not hurt to put that in parentheses. Number 8 down here, we have the log base 5 of an expression plus the log base 5 of a different expression. But because we have the sum of 2 logarithms, we can again write this as the logarithm of a product. And so the product is going to be x minus 2 times x plus 2. We will go ahead and multiply that together and simplify it to become log base 5 of the expression x squared minus 4. Do put that x squared minus 4 in parentheses. The next thing we're going to talk about is how to evaluate logarithms that are not common logarithms or natural logarithms using our calculator. And for that, we're going to use something called the change of base formula. So the change of base formula tells us that for any positive base with a positive expression, we can rewrite this as the logarithm of some particular base of this u divided by the same logarithm of the base. Now we're going to take this a step further, and I'm going to tell you to use the natural logarithm here. So rather than using log base a, we're going to use the natural log of u divided by the natural log of b. This is going to be a better way to do this. You can use common logarithms, but we're going to use natural logarithms. Now, if I want to get an approximate value, then that's what I'm going to do here. So I'm going to start with, I'm going to write this as a quotient, and this is going to be the natural log of 51 divided by the natural log of the base, which is 4. And we'll put this into a calculator. When we put this into a calculator, and it does say to round to 4 decimal places, so the natural log of 51 is going to be a value of 3.9318, and we'll go ahead and take that to 5 decimal places too, and then we'll divide this by the natural log of 4. The natural log of 4 is 1.38629, and when I divide that out, then I am going to get, and we will simplify that, round that at the very end, 38629, we're going to get 2.8362, and that is going to be my final answer. For number 10, we're going to do exactly the same thing. We will start with the natural log of, yes, 0.8 or 0.8, if you want to type it in like that, either way is okay, divided by the natural log of the base, which is 7. You can actually put all of this into your calculator at once. I will give you that final answer for this one. If you type in the natural log of 0.8 divided by the natural log of 7, it will give you negative 0.11467, but since it says to 4 decimal places, our approximate answer is going to be 1147. Don't forget your negative in front, and that is my final answer. All right. Now that ends section 5.3. So if you want to stop here and come back and revisit 5.4 later, you're welcome to do so. Or we can move along with the first couple of problems in section 5.4. So in section 5.4, we're going to talk about solving exponential equations using that natural logarithm. So I'm going to give you a very quick reminder over here. And this is the reminder that when we took the natural log of e to a power, we always get that power. And this is what we're going to be using here. Now, back in section 5.1, we also talked about solving exponential equations that had the same bases. This method that we're going to talk about in this section can also be used to solve those exponential equations. But it works very nicely when we don't have things where we can rewrite them with the same base. For example, if I wanted to solve the equation 3 to the x is equal to 5, I can't write 5 as 3 to a power. So using this natural log on both sides is what's going to allow me to solve this equation. So just like any other equations that we solve, as long as we do the same operation to both sides, everything is fine. So we're going to take the natural log of both sides. So I'm going to take the natural log of 3 to the x, and this is going to be equal to the natural log of 5. So literally I'm taking the natural log of both sides. Now on the left-hand side, this x is going to come down in front using that power rule that we just talked about in this section. And so x times the natural log of 3 is going to be equal to the natural log of 5. In keeping with solving an equation, I'm going to divide both sides by the expression that's multiplied by x. So I'm going to divide both sides by this natural log of 3, dividing both sides by this natural log of 3, and I'm going to get on the left-hand side x is equal to, the problem says we first express our answer in terms of the natural logarithm. So this is our first part of the answer. The second part says we want an approximate value. So our approximate value is going to be what happens when we plug this into the calculator, finding the natural log of 5 divided by the natural log of 3, and that's going to be 1.4649 7. I went ahead and took it out to 5 decimal places because I want you to see what happens here. This is actually going to round up to approximately 1.465. You can put the 0 or not, and this is perfectly acceptable. Sometimes it rounds up a little bit further. Okay. Problem number 2, we're going to do exactly the same thing. We're going to take the natural log of both sides. So on the left-hand side, we have the natural log of 2 to the x over 3 power, and this is going to be equal to the natural log of 19 on the right-hand side. On the left-hand side, that exponent of x over 3 is going to come down in front using that power rule. So I have x divided by 3 times the natural log of 2 is equal to the natural log of 19. Dividing both sides by the natural log of 2 is going to leave me with x over 3 is equal to the natural log of 19 divided by the natural log of 2. I would not put this in the calculator just yet because we still have to get this answer in terms of the natural logarithm. So to do that, to get rid of the 3, I multiply both sides by 3, and that's going to give me x on the left-hand side is equal to 3 times the natural log of 19, all divided by the natural log of 2. Now, plugging this into your calculator, I would do 3 times the natural log of 19, close any parentheses you have, divided by the natural log of 2, and that's going to give me a final answer of 12.743, and it's 78, but I'm going to round it to 38 because of the 4 decimal place rule. All right, excellent. These next two problems, and these are the last two in this section, notice that the base for both of these is e, whereas on the previous two problems, our base for our exponent was not e, so that we had to do a little bit more work. These problems are a little bit nicer. We're still going to do the same thing. We're going to take the natural log of e to the x plus 7 power on the left-hand side is equal to the natural log of 20 on the right-hand side. When we use the power rule to bring this exponent down in front, that entire exponent is the expression x plus 7. You might want to put that in parentheses. You don't have to. It just might make it a little bit easier. I almost wrote that natural log there. Okay. We're just going to go back. We'll just write this as x plus 7. So the natural log of e to the x plus 7, the natural log and e cancel each other out, and we just get that x plus 7 is equal to the natural log of 20. Now, because it does tell us to express this answer again in terms of natural logarithms, I'm going to leave this here. I'm going to now subtract 7 from both sides, and so I have the x is equal to the natural log of 20, and then minus 7. You could also write this as negative 7 plus the natural log of 20 if you think that's going to get you in trouble. Do not subtract 7 from 20. That's the big thing there. Either one of these answers is okay. Now we want to get an approximate answer. We're going to find the natural log of 20 using our calculator. And then from that value, we're going to subtract 7. And we're going to get negative 4.0043 when we round that to 4 decimal places. So this is my approximate answer. Okay. Number 4 is a little bit different in that I have this number that's in front of or multiplied times my e to the power. So the first thing I have to do is to divide both sides by 150. So before I can solve anything else, we have to divide both sides by 150. That's going to give us e to the x minus 4 power on the left-hand side is equal to 5 divided by 150 on the right-hand side. If you would like to simplify 5 over 150, you can. 5 divides into 150. That's going to leave me with 1 over 30. A little bit easier fraction. I probably would not get the decimal value there. Let's now solve this by taking the natural log of both sides. So the natural log of e to the x minus 4 is going to be very nice. This is going to be equal to the natural log of, please notice I am going to put 1 over 30 in parentheses. This is going to be very important that you do that. On this left-hand side, the natural log of e to the x minus 4 simply becomes x minus 4. And this is going to be equal to the natural log of 1/30. Going to add 4 to both sides, and so I get x is equal to 4 plus the natural log of 1/30. This is my answer in terms of a natural logarithm. My approximate value, once I substitute this into the calculator, and I can actually type in 4 plus the natural log of 1 divided by 30, and that is going to give me 0.5988 for my final answer. That concludes the first part of section 5.4. Like I said, the second part will be in a separate video, but if you'd like to watch them all together, you are welcome to do so. Have a great day.